Hi, thanks for coming. So today we will talk about getting to know your data. So you are going to want to understand the following: what kinds of characteristics or areas make up your data? What are the values of each attribute? What are the discrete characteristics and which are continuously valued? What is the law of the data? How are the values distributed? Can we visualize the data in order to get a better sense of it all? Can we find outliers? Can we evaluate the resemblance between some data objects and others? The subsequent assessment will assist to gain such insight into the data. So knowledge of your data is helpful for pre-processing data and first important task of the data analysis. So data objects and attribute types. So they are data tuples if the data objects are stored in a database. So data set consists of objects of data. What is an attribute? So an attribute vector or future vector is a collection of characteristics used to define a specified object. An attribute is a data field that represents a data object's trait or function. So nominal implies name related. Nominal attribute values are symbols or names of stuff. Both hair color and marital status are nominal attributes. So this is an example of the nominal attribute. So binary attribute is a nominal attribute with only two states, 0 or 1, where 0 typically implies the attribute is missing and 1 means it is present. A binary attribute is symmetrical if both of its states are equally valuable and have the same weight. There is no preference as to which result should be coded as either 1 or 0. So one such instance might be the gender characteristic with male and female states. So a binary attribute is asymmetric if the results of the states, such as the favorable and negative results of an HIV medical test, are not as important. By convention, we code the most important outcome, usually the rarest. 1 stands for HIV positive and 0 stands for HIV negative outcome. So ordinal attributes. Ordinal attributes are useful for the registration of subjective qualities assessments that cannot be objectively measured. Therefore, ordinal attributes are often used for ratings in surveys like this one. So numerical attribute is quantitative. That is, it is a measurable quantity represented in real or integer values. Interval scaling or ratio scaling or numeric attributes. So interval scale attributes, temperatures in Celsius and Fahrenheit, do not have a true 0 point. There is neither 0 Celsius or 0 Fahrenheit indicates no temperature. On the Celsius scale, for example, the unit of measurement is 1/100 of the difference between the temperature of melting and the temperature of boiling water in atmospheric pressure. So there is an interval scale, a temperature attribute. Other examples of ratio scale attributes include count attributes such as years experience. For example, objects are employees and several words. For example, objects are documents. So the ratio scale also can use to um, calculate weight. So discrete attribute has a finite or countlessly infinite set of values that can or may not be represented or as integer values. If the set of possible values is infinite, an attribute is countlessly infinite. But the values can be placed in one-to-one correspondence with natural numbers. It is continuous if an attribute is not discrete. In literature, the terms numeric attribute and continuous attribute are frequently used interchangeably. So, the basic statistical descriptions of data. So basic statistical descriptions can be used to define the data's characteristics and highlight the data values that should be treated as noise or outliers. To be successful in pre-processing data, an overall picture of your data is essential. So you can see there's a mean, median, mode. So you can search how this happening, how how to calculate mean, median, mode on the internet. So there are a lot of example um, there. So we are now looking at measures to evaluate the dispersion of distribution of numerical data. So the range, quartile, percentile, and interquartile range, so or we call it IQR measures can be calculated. So you can do some research about this five number, which is the distribution summary that consists of the median, Q1, Q2, median Q2, Q1, and Q3 quartiles, and the smallest and largest individual observers, which is minimum and maximum number written in. So start with minimum, Q1, median is Q2, right? Q3, and maximum number in order. So in order to do this in a box plot, so the whiskers are extended to be extreme low and high observations. If these values are below 1.5 above the quartiles. So they show how to spread the distribution of the data. So graphic display of basic statistical distribution of data. So this includes quantile plots, which is a QQ plot. So histogram, scatter plot. So such graphs are helpful for the visual inspection of data, which is useful for data pre-processing. So measuring data similarity and dissimilarity. So a cluster is a set of data objects in such a way that the objects in a cluster are identical to each other and different from the objects in the other clusters. So the higher value of dissimilarity, the more the two objects are distinct. So two data structures widely used. The data matrix, so you can see on the screen. So used to store dissimilarity values for object pairs. So for objects defined by nominal attributes, binary attributes, numeric attributes, ordinal attributes, or combinations of these types of attributes, object dissimilarity and can be determined. So this offers similarity tests for very long and sparse data vectors, such as vectors of term frequency describing documents in the retrieval of information. So knowing how to quantify dissimilarity is useful in the study of clustering features, alliances, and nearest neighbor classification. So thank you for watching. So next, live streaming, I will explain more about data processing. Thanks for watching and good night.